Hello everyone, welcome to Chemistry Radio Lab. Thank you for all joining us this fine evening. Today we are going to be talking about paraffin wax. But what is paraffin wax? Well, I'm glad you asked.
First, let's talk about how this substance is produced. Well, it all starts with fractional distillation. This is when petroleum is put at the bottom of the fractionating column that looks like this. The column is then heated and petroleum reaches its boiling point, transforming into steam. The steam rises and goes through different chambers, and these chambers are heated at different temperatures. There are different molecules within petroleum, each with different boiling points. This means they will condense from steam to liquid in different chambers in the column. There are trays within the chamber to collect the condensation of these substances. And one of these substances is oil lubricant. And since it has an intermolecular force of dispersion, it has a high boiling point of around 600 degrees Fahrenheit. And the byproduct of this is slack wax, and that is where paraffin wax comes from. Slack wax looks a bit like animal fat or tallow, but it is not yet the paraffin wax that we are looking for. Now, the process of extracting the paraffin wax from the slack wax is quite interesting and actually beautiful in its own unique way. To extract the paraffin wax, the manufacturers have to use the process of crystallization. Sounds pretty wizardy if you ask me. To do this, slack wax is heated up to its melting point around 150 degrees Fahrenheit so it becomes a liquid. And then they add a solvent, usually in the form of a ketone. And then they let it cool. Now this is where the really cool part happens. The liquid starts to crystallize and become paraffin wax. We couldn't find a video of paraffin wax crystallizing, but here's some other crystallization clips so you guys can get a visual of what happens. Now, that was pretty cool, but the process is still not done. There is still leftover oil mixed in with the newly formed wax. This is filtered out using rotary drums. And now, the process is done. You have paraffin wax.
Now let us see what this thing looks like on the atomic level. First thing you're probably going to see is that there are only two elements in this molecule, hydrogens and carbons, and that they're in a long chain with carbons in the middle and hydrogens on the outside. The chemical formula for this can be represented by the equation CnH2n plus 2. For example, if you had 10 carbons, there would be 22 hydrogens. 2 hydrogens go on either side of the carbons in the middle, and the very ends have 3 hydrogens. Now let's talk about some polarity and intermolecular forces of paraffin wax. Since it only has carbons and hydrogens, one atom is not more electronegative than the other to create any polar bonds. Therefore, this is a non-polar molecule. Also, its intermolecular force is that of dispersion, meaning that there is little force between molecules. The structure of paraffin wax has a huge effect on its properties and how it is used in everyday life. Paraffin wax is a super useful material and used in many products. When it was first invented in the 1850s, paraffin wax completely took over the candle market from tallow or animal fat. This was due to it being really easy to produce, much easier than whaling. And remember how we said paraffin wax had an intermolecular force of dispersion? Well, one of the properties of dispersion is a low melting point. This also helped paraffin wax take over the candle market, and it held that position for 150 years. But it doesn't stop there. Paraffin wax is a nonpolar molecule, which also means it does not mix with water. It is also quite malleable or mushy, like Play-Doh. This gives it many uses. To name a few, wax paper coating, surf wax, ski wax, glide wax, and bullet lubricant. One last use which I find super interesting is in crime scene investigation, where they use paraffin wax to pick up potassium nitrate, which is a gunpowder residue. The reason why they can do this is because both are nonpolar molecules. To wrap this up, we're going to talk about the environmental impact of the substance. First of all, to get the petroleum which is needed for paraffin wax requires drilling, or fracking. This can have a really bad effect on the environment. This was seen in the BP oil spill of 2010. when an oil rig exploded, causing the destruction of many animal habitats in the Gulf of Mexico. Another impact that occurs is during the fractional distillation stage. Even though the column itself does not produce any pollution, what heats it up does. The fire that heats the column is usually powered by coal, and this gives off thousands of pounds of CO2 emissions every year, creating global warming, melting polar ice caps, creating rising sea levels, and making this guy without a home. There is one last impact this substance has, and this is due to the fact it is non-biodegradable. This means after a paraffin wax product is done being used, it will sit in a landfill. Crayons alone, a paraffin wax product, make up 75,000 pounds of trash that are put in landfills every year. This type of pollution can have an impact on an environment for decades, if not centuries. Paraffin wax is a really cool substance. The production of it is cool, and its uses too. But it all comes at a price. Is it worth it? You decide. See y'all in the next one.